Children, today you will learn about the simple machines. Now, what is work? Work is said to be done if the force applied on the body moves it. See the example which is given over here. Here you can see that the person is moving an object. That means this person is doing some work. That is, when he is applying force on this load, it is moving forward. That is, it is changing its position. So, this person is said to be doing some work. But see in the second figure, here the person is trying to push this heavy box, but he is unable to. Though he is applying force, we will say that no work is done over here because he is unable to move this object. So, here no work is done. That is, if no motion or change in position takes place, no work is said to be done. Energy. Energy is the capacity or the ability of a body to do work. So here, in both the cases, energy is the capacity or the ability of these two persons to do work. In the first case, here energy is needed or applied. In the second case, also energy is needed and applied, but here we do not find any change in the position of the object. Actually, energy and work are related to each other. So, the SI unit for both work and energy is joule. It is also said that work done is equal to force into distance moved by the body in the direction of force. Principle of a machine. A machine cannot do work by itself. That is, a machine can never do any work on its own. Energy needs to be supplied to it. That is, when energy is supplied to it, then it does some useful work. To do work on a machine, force is applied. So this applied force on that object is called the effort. So when a machine needs to be worked, then energy has to be supplied. So the force which is applied on the machine is known as the effort. And the resultant force, that is, the work that is being done by the machine, that is, if it is lifting or moving the object, that is the load in order to do the work. So, a machine does not work by itself. So, when energy is supplied to it, then it does some useful work. Efficiency of a machine. The efficiency of a machine is the ratio of the useful work done by the machine to the work put into the machine by the effort. That is, efficiency is the useful work done by the machine on the load divided by the work done on the machine by the effort. Ideal machine. A machine in which no part of the work done is wasted is called an ideal machine. For an ideal machine, the work output is equal to the work input. That is, it has to be 100%. Do you think that an ideal machine exists? Never. An ideal machine cannot exist because no machine is perfect. Whatever work we do on that machine, the output will be always less than the work input. So, ideal machines are machines where no part of the work is wasted. Here, the work output will always be equal to the work input. That is 100% of the work is done. Actual machine. No machine is perfect because some part of the work done is used up in overcoming the friction between the parts of the machine. So, work output of a machine will always be less than the work input. So, no machine is perfect because the part of the work done on the machine will be used up in overcoming the friction between the moving parts of the machine. Therefore, the work output of a machine is always less than the work input. That is, the efficiency of an actual machine will be less than 100%. So, if we say that a machine is 80% efficient, it means that 80% of the work input to the machine is obtained as the useful work output. That is, the remaining 20% is wasted in overcoming the friction. Functions of a simple machine. It increases the magnitude of the force required. That is, effort is less than load. For example, see this car over here. This is being lifted up by a jack. What do you observe? That this jack, which is used to lift a car, is doing some work. That is, the effort which is applied on the car to move it up will be much less. That is, the magnitude of the force here is increased. Second point, it increases the distance moved by the load. See the second example over here. In a pair of scissors, the arms are longer on cloth than its handle while in use. So you can see over here that the arms of the scissor are moving forward. But here less effort has to be applied to move forward over in this direction. That is, it increases the distance moved by the load. Third point, it changes the direction of effort in a convenient direction. See the example of the pulley over here. You must have seen a well. What happens? How do people take out water? So they always use a pulley, as you see over here. Now you have a rope which is tied to this bucket. Whenever a person needs to take out water from a well, this bucket is lowered down, and when the person is pulling the rope from this side, the effort needed is less and the load will come up very easily. That is, here the direction of effort, we are pulling the rope downwards, but the load is moving upwards. That is, the direction of effort is changed into a convenient direction. The fourth point, it changes the point of application of effort to a convenient point. See this figure over here. Here you can see that the bicycle, the rear wheel is joined with the help of a chain to a toothed wheel which is attached with a pedal. So all of you must be having bicycles. You must have seen that there is a chain-like structure which is present over here, to which the pedal is attached. Now why it is attached in this way? So the rear wheel of the bicycle is joined with the help of a chain to a toothed wheel which is attached with a pedal. So when the pedal is rotated, then the wheel also automatically rotates. That is, lesser effort is needed to be pedaled. So the bicycle moves forward. So in other words, we can say that a machine is a device which enables us to exert a force greater than the force applied to it, or to apply a force at a convenient point, or to apply a force in a desired direction, or to move the load longer than the effort.